I will talk just for a few minutes about trends in quantum in general. And I'm actually not going to talk so much about specific trends, just how we at GQI think about trends in quantum. And if anybody is curious to learn more, please find us later. At GQI, Global Quantum Intelligence, we are a market and business intelligence provider. I don't think they're in the room, Gartner, Forrester, if you're familiar with those kind of companies. But all we do is quantum technology. So we work with the vendors in quantum, but mostly with governments and with investors to offer them market and business intelligence for their decision making. Here are some of the examples. We'll skip that. We're 19 people in my team. Half of them are PhDs in quantum. The rest is tech or like my background in consulting. But when we do work, and just kind of a setup, I'll go to the next slide here. I was jokingly telling this to somebody at breakfast. It's the consultant in me. We don't give you answers. We want you to have more questions, right? So I'm also not going to give you very many trends. We just give you a lot of frameworks and a lot of data. And then, of course, we either try to scare you or we try to excite you. And all of this, I will get to this in the next slide, is based on a lot of intelligence that we gather. We'll talk about that in a second. But our next speaker, Donner, will talk about security in quantum. This, of course, is one of the big triggers, right? When is quantum finally going to be able to supposedly break RSA encryption? And you have the common narrative in the industry, and Worley showed Time magazine and in the news and media. And then we have what's actually possible. And we're not saying that's when it's going to happen, right? But this is a typical conversation starter. So as a consultant, what we give you is not answers, as I mentioned, but frameworks and data. And where we get our intelligence from is a lot of data gathering through scrapers, news, media, databases, and so forth. A lot of human intelligence. And a lot of due diligence. This week alone, we have 13 active due diligence deals in quantum technologies. 11 of them are quantum computing hardware for $1.5 billion. And you saw this on Worley's slide. Last year was $1.4 billion in venture capital globally, which is completely insignificant, right? But so we have a very good view, and we have frameworks that, if I can find the pointer, that kind of look at the entire, if you're an investor and you're curious about, is there a TAM, a $50 trillion TAM, or $1 trillion TAM, or any TAM that's exciting, we have frameworks for this, right? What does your ecosystem look like? What does your competition look like? Where do you generate your value? What are your business models? What are your deployment models, and so forth? And then we go into the technology. So that's where you pull out the screwdrivers, go on site, and bang up the hardware, interview everybody, and test everybody. So we have tremendous, in the last year and a half, we've done 26 due diligences. So if you were to do kind of a mental list of the top 40 startups in quantum, 26 of those, we know their roadmaps, we've tested their non-public kind of hardware, and that's where all of this intelligence comes from. The first kind of trend, we already saw that this morning, or this afternoon, I should say, sorry, it's not morning, is of course we talked a lot about the mid-stack, right? This whole era of error correction, error mitigation, error suppression. Listen, a year, for those of you that have been in the industry, and I see many that are, 18 months ago, we barely had a handful of credible quantum computing hardware vendors, right? That had public roadmaps that really showed some sort of NISC or utility and a credible path towards scaling. Today, we probably have close to 10 of those. And as Willie just pointed out, they aren't at industrial scale yet, of course. You saw the announcement of PsiQuantum on the south side of Chicago with a big chip manufacturing facility. We're starting to see the early days of M&A, acquisitions, industrialization, and so forth. So, the middle of the stack, the fact that there's more and more full stack providers, and increasingly a move towards the top of the stack where you have algorithms and applications is really what folks are working on these days, because the qubit plane hasn't been conquered yet. There's still a lot of work that needs to be done. We saw that earlier, right? But it is very well understood. It is very well engineered. and it's not where people tend to spend their time on today. And when we get asked about, and that's what I meant when I said I'm not going to give you the trends, just how we think about it. When we get asked about, so which quantum computer will bring utility, which quantum computer will break Shor or reach fault tolerance, consulting answer, it depends. Steve Riley from Riverlane, sorry, this was one too many, this morning introduced this concept of QOPs, quantum operations per seconds. We're of course currently in the kilo-QOP era, barely. But what you have to see, and here we have in green and red 2 hypothetical quantum computing vendors that we might compare in an assessment. Just because somebody is doing well today in the foundational or kilo-QOP era and has a roadmap that is very credible for kind of the next couple steps, and we see that at these conferences a lot, doesn't necessarily mean that they will do well if they need to scale to a larger fault-tolerant or even Shor era-capable regime. And startups that you hear from very little, or maybe on the little side panels, that barely built their first qubits and haven't really demonstrated large-scale systems yet, might have technology that at the end will scale very well. And all of this goes back to different layers of the stack and different strengths here. So the first thing that we look at is how does technology compare, think of technical readiness levels across these different performance eras. And then of course timelines, because everybody and many timelines are out there when folks will reach 100 logical qubits or fault tolerance or utility. You then have to overlay this with the timelines, just simple engineering and how long this takes. And when you do all of that, you will see that currently, based on roadmaps published, not many are left when it comes to being able to deliver on that. A lot of work needs to be done, my French and Australian friends. So here is, of course, the different modalities. You see the stack again. Green is something light green that's in prototype or commercially ready. Red, of course, full red isn't on here, is something that's still a lab proof of concept or still needs to be delivered. And this is something that we've been doing since 2018, 2019. I'm trying to figure out how to get an animated version of this shard. But as recently as 2 years, all of this up here would be white or gray, unknown or not yet demonstrated. And you had very little green down here. We also break this down vendor by vendor. We have over 45 quantum computing vendors with all their data. So the big trend here is that you have more and more companies that, even if it's light or dark red, and all of the major modalities that have delivered and shown progress across the full stack, and pretty much everybody has really strong progress at least the qubit plane, which again goes back to this fact that that most attention now is spent at the middle of the stack. The scaling challenges, I think all of you know them. This slide is a little botched from the download, sorry about that. I think the scaling challenges are well known. Here's a summary. We actually just yesterday announced a project that we're doing for NATO, where they're asking us the question, which quantum computing vendor is theoretically able to break Shor? This is what you need to achieve. This is what is standing in between today and potentially breaking Shor from a hardware point of view. So all of these are trends. We can discuss them in detail, but I'll let you look at them just for a second. Then of course there's a whole bunch of other problems. Algorithms is something that still doesn't get enough attention, also at conferences like this. Today, if Nicolas or Andrew would give us this fault-tolerant quantum computer, what can we do with it? Do we have the use cases? Do we have the algorithms to actually work on it? Do we have stuff that really gives us the necessary speed up? And if you overlay this, go talk to Scott. I would love to see his database of use cases. If you overlay these use cases with the speed up that you can get, which we tried to do, the picture is pretty bleak. So there is some potential out there, and this goes back, sorry for switching back and forth, to some of the deployment modes as well, and these inflection points that might accelerate this. But a lot of foundational work, remains to be done. This is my favorite chart. As a consultant, you get really excited, but what this does, of course, is it looks at the timeline, it looks at the scale of it, and then it shows you, this is what we call scenarios. Think of it as product maturity, how you get from today to something that eventually scales. And there, of course, another big trend in the quantum computing industry, at least, is interconnects or modularity. And that's one of the other big topics that folks are working on today. And I'm trying to give a couple minutes back to our next speaker because we're running late. But just so to share this, we have similar frameworks when it comes to kind of software, platforms as a service, integration as a service, and so forth. And here the trends, sorry, I didn't mean to click yet. Here the trends are that we don't have a full stack yet, right? Whatever you look at in terms of solutions, software, services, and algorithms, it's still a relatively small universe. And while these products or features individually are relatively mature and have been for several years, actually, we still don't have a full stack across this. Same argument here. I'll skip this one, PQC, QKD. We also look at sensing, but I will give that time back to our next speaker. Donna, are you here? We'll wrap up. I want to show you one more slide. This is interesting. It shows 33, yep, so we track 33 national programs. This screenshot from our live database is 6 months old. We're now at 42. So the number of countries that have officially declared a national program that has some sort of funding, and we then assess them on a PESTEL framework, which is another typical consulting framework, political, economic, social, technological, environmental, and legal impact. This is scored from 0 to 5. And you see that all of them have relatively good scores, but there's very little disparity. There's very little differentiation between these programs, which just speaks to their maturity. Individual initiatives are nice, they're funded, they're well thought out. As overall programs, they are still looking for definition. Funding, Worley talked about that. SPACs will forget. National programs, we just said. Just one last, because Scott is still here. We now have, I think, 210 use cases in our database. Not all of them are in this data visualization yet. 176 here. We kind of try to categorize them by status, proof of concept, and deployment, and we can argue about our classification, but when you look at that classification, 6 of those 176 use cases are in deployment, and all of them are annealing and hybrid. Still a young industry. Hopefully this gave you a little bit of an idea of how we think about trends and baselines, references, benchmarks in quantum. If you want more answers, we'll talk about that. But an important topic, and Evolution Q is talking about it, so we're excited to have Donna here, is of course quantum security. As I showed on one of my first slides, we believe that day might be closer than many think. Donna, what do you think? Please.